Okay, today we are going to discuss input-output analysis. Input-output analysis is developed by the economist Vasily Leontief, and for this contribution, he was awarded Nobel Prize in Economics in 1973. Now, what is the crux of this model? It says that economy is divided into several sectors, and all these sectors are interdependent. Okay, that is an economy. You can find sectors like agricultural sector, industrial sector, service sector, etc. And each sector will be producing a product. And all these sectors are interdependent because to produce a product, the sector will require inputs from its own that is sector, and it also requires inputs from other sectors. For instance, for production to take place in agricultural sector, you require some inputs from agricultural sector. You also require inputs from other sectors like manufacturing sector, service sector, etc. So that is why we say that there is interdependence among these sectors. Now, the total output produced, it is distributed in two ways. One, it is to meet the internal demand, that is, it goes as input into that very sector which produces that product, and it is also going as inputs in the production of various other products of the other sectors. So that constitutes the internal demand. Apart from that, there is also an external consumption demand. So the total output produced by each sector that goes to satisfy both internal demand and also external demand. Now, let us examine this concept using an example. Okay, before we discuss the mathematical model, let us take the case of three sectors. You have sector 1, sector 2, and sector 3. Now, it is stated that sector 1, in order to produce 1 unit of that product of sector 1, sector 1 is producing a product 1. To produce 1 unit of that product 1, the sector 1 requires its own product as its input. It is stated that zero point 0.1 unit of the product 1 is used as input by that sector 1. Then it also requires zero point 0.2 units of the product 2 for producing 1 unit of product 1, and it also requires 0.25 units of product 3 to produce 1 unit of product 1, right? That is what is the case in sector 1. Now sector 2, it is producing the second product 2. Now to produce that 1 unit of product 2, this sector, it requires 0.15 units of product 1. Okay, product 1 is actually manufactured in the sector 1. So in order to produce the product 2 for the second sector, it requires 0.15 units of product 1. It requires 0 units of product 2. That is, it doesn't make use of its own product as its input. And it also requires 0.40 units of product 3. There is another sector 3 which is producing another product 3, and 0.40 units of product 3 goes as input into the manufacturing of 1 unit of product 2. So that is the case of second sector. Now there is another sector 3. It is producing the third product 3. To produce that 1 unit of that product, this sector requires 0.12 unit of product 1, and it requires 0.30 units of product 2, and it requires 0.20 units of its own product, that is product 3. Now these constitute the input demand or the internal demand. In addition to that, there is consumption demand, final demand, where for the product 1, the demand is equal to D1 is equal to 100. For this product 2, demand is equal to 200. For the product 3, the demand is equal to 300. So this is the information that we have. Okay, so this shows that all these sectors are producing a product. Sector 1 is producing product 1, sector 2 is producing product 2, sector 3 is producing product 3, and all these sectors are interdependent, because to produce 1 unit of product 1, you need the input from that sector 1 itself, and also you require inputs from other sectors like sector 2 and sector 3, and that is the same case for sector 2 and sector 3 also. To produce their respective products, they require inputs from their own sector and also from other sectors. Right, now this information, let us present it mathematically. Now let us say, to produce how much of x1 has to be produced. That is what we have to decide. Okay, that is to produce x1. Of course, we know that to produce, that is how much of x1 is to be produced. That is x1, it is going as an input in its own product. It is also going as an input in the products of other sectors like product 2 and product 3. So based on that information, we can say that how much of x1 is to be produced. It can be written as point, isn't it? So 0.1 unit of x1 goes as input in its own product. So it can be written as 0.1 into x1 plus, again in the case of second product also you require 0.15 unit of product 1. So that can be written as 0.15 x2 plus. Now in the case of product 3, to produce 1 unit of product 3 you require 0.12 unit of product 1. So you can write this as 0.12 x3. So this is the input demand for x1. Okay, x1, how much unit of x1 is to be produced. So the input demand can be represented in this way. To produce x1, it requires 0.1 unit of x1. To produce x2, it requires 0.15 unit of x1. To produce x, that is third product, it requires 0.12 units of x1. Now similarly, you can write x2's total output to be produced based on the input demand. Of course, to produce x1, 1 unit of x1, you actually require 0.2 units of that is x2. That's so it can be written as 0.2 x1 plus. And again, here we see that for producing the product 2, it doesn't use its own that is product as an input. So we can write this as 0, that is x2 plus. And again, for the third sector, it requires 0.30 unit for as input for producing product 3. So it can be written as 0.30 x3. Right? And how much of x3 to be produced? X3 is actually used as input in the production of first product, second product, and third product. So again, that can be shown here. So 0.25 x1 plus 0.40 x2 plus 0.20 x3. So that is how we write the input demand. Okay, so the total demand consists of internal demand and external demand, and there is also an external demand, that is D1 is equal to 100. For the first product, you have a demand that is equal to external demand that is equal to 100, and for second product you have an external demand equal to 200. For the third product we have an external demand that is equal to 300. So this is the information that we have. Now, this can be translated. Okay, what we have presented here, this can be actually presented as in mathematical form. Okay, this x1, x2, x3, this is actually presented in a matrix form. Okay, this information, that is, suppose if you're writing this here, the same thing what we have written earlier, if you're writing it in this, the same information is presented here, 0.1 x1 plus 0.15 x2 plus 0.12 x3, and similarly x2 is equal to 0.20 x1 plus 0 x2 plus 0.30 x3. Now coming to x3, it is equal to 0.25 x1 plus 0.40 x2 plus 0.20 x3. Now this information can be presented in a matrix format. We can write this as x1, x2, x3. You are writing it as a column vector. It is equal to, you write all the coefficients and form a coefficient matrix. 0.1, 0.15, 0.12, here 0.20, 0, 0.30, 0.25, 0.40, and 0.20. And you form a coefficient matrix and multiply it with x1, x2, and x3, form a column vector. So that again, you, of course, this is the internal demand, and also you have an external demand which we have mentioned earlier. I think it is 100, let me see, let me check. It is, yes, it is 100, 200, and 300 plus 100, 200, and 300. So this is how we have translated that problem into a matrix format. Okay, so this can be again summarized as this column vector x1, x2, x3 can be presented as x is equal to, this is actually a coefficient matrix, which can be written as A, and this is again a column vector AX, okay, plus D. This is the external demand. Now you can rewrite this as X minus AX is equal to D. Now you take X out of brackets and you get X into I minus A. Okay, X into I minus A is equal to D. Remember that this is actually a matrix. Okay, that is, this X actually represents this column vector. A represents a coefficient matrix. This is again X is again a column vector. D is also a column vector. So this is basically a matrix, isn't it? So X minus AX, and when you factor out X, what is remaining, instead of 1, we are writing it as I. This is I is actually an identity matrix. Okay, of course, in metrics you have studied what is an identity matrix. You know that identity matrix or a unit matrix is 1 0 0 0 1 0 0 0 1. So this is how you form a identity matrix. So this is how you solve it. X into I minus A is equal to D. So from this you write X is equal to, this can be written as I minus A. Okay, I minus A inverse. Again, that is something you have learned earlier. That is, instead of writing 1 by X, you usually write X raised to minus 1. Similarly, 1 by I minus 1 by I minus A, that can be written as I minus A raised to minus 1, or it is in matrix parlance we call it I minus A inverse into D. Right? So now how to solve for X? X, we know that this is how much units of first product, second product X2, and third product X3 to be produced. That is what we have to decide. How do you arrive at that solution? You take I minus A inverse into D. That is, you have to find inverse of the matrix I minus A. I minus A is the Leontief matrix. Okay, it is called the Leontief matrix, and you have to find the inverse of this I minus A, right? Now, of course, you know how to find a inverse of a matrix for any square matrix that is non-singular. Of course, I'm sure since you have learned matrix, you are familiar with all these terms. For a for a square matrix that is non-singular. Non-singular means the determinant of I minus A, it must not be equal to 0. Only then you say that it is a non-singular matrix. Okay, and it must be a square matrix where number of row and number of columns must be equal. So for a square matrix, which is a non-singular matrix, you will be able to find the inverse of that matrix. So what you have to do is that first you have to find what is I minus A. I is actually identity matrix. A is this matrix that we already know that. This is that matrix. So first you have to write what is I minus A. Okay, you have to form that I minus A matrix, and that is equal to 1 minus 0.1. Okay, 1 minus 0.1, that is 0.90. Then 0 minus 0.15 minus 0.15. Then again here you have 0 minus 0.12, there is 0 minus 0.12. Then again you can apply the same technique. I minus A can be found out. That is minus 0.20. Then you have 1, and then minus 0.30. Then again you have minus 0.25 minus 0.40. Then you have 0.8, isn't it? That is 1 minus 0.20, that is 0.8. So this is how you find the I minus A matrix. Now you have to find the determinant of I minus A. Okay, because it must be a non-singular matrix. Of course, it is a square matrix where you have number of rows and number of columns happen to be equal. Now you have to find whether it is non-singular or not. For that, you have to find the determinant of this. Now you just compute determinant of this. I have already computed it, and I have found it to be 0.53715. Okay, so which means it is not equal to 0, isn't it? I minus A, determinant of I minus A is not equal to 0. So it is basically a non-singular matrix for which you have an inverse. So you can find I minus A inverse can be found out. Okay, now the next question is how to find out this inverse of a matrix. Okay, of course, how to find this inverse of a matrix? It is given as adjoint of A or adjoint of I minus A by, okay, determinant of I minus A. Isn't it so? That is how you find out the inverse of a matrix. Isn't it so? That is how you calculate inverse of a matrix. Again, you have learnt all that earlier. It is adjoint of I minus A by determinant of I minus A. Determinant of I minus A has already been calculated. Now, next we have to find it. What is determinant of, sorry, adjoint of A. Okay, just a minute. Now let's calculate adjoint of A. Let me erase this because to calculate adjoint of A, first of all, you need to calculate the cofactor matrix, isn't it? So you need a cofactor matrix. Okay, so for finding out the cofactor matrix, first of all, you have to find what is the minor for each of these values. You have a minor. You have to find what is M11, what is M12. I'm sure you know all these things. What is M13? Then you have M14, M15. Sorry, that's wrong. M13, then you have M21. It's actually 3 by 3 matrix, isn't it? So you don't have there is a M14 and all. Just a minute. Yeah. Mm. Then you have M21, M22, M23. Then you have M31, M32, and M33. Of course, I'm sure you know how to calculate minor of a matrix. That is to find out M11, you take 0.90, you delete the first row and first column, and then what is remaining is 1 minus 0.30 minus 0.40 0.8. You find the determinant of those values, isn't it? 1 minus 0.30. Okay, that is minus 0.40 and 0.8. You find the determinant of those values. When you find M11, it is equal to 0.68. Similarly, what is M12? For M12, you delete or you strike down the first row and the second column. Then what is remaining is minus 0.20 minus 0.30. Then here you have minus 0.25 and 0.8. Find the determinant value, that is equal to minus 0.235. Similarly, you find M13 again for that is M13. You delete the first row and the third column, isn't it? First row and third column. So what is remaining is minus 0.201 minus 0.25 minus 0.40. So that process goes on. Calculate the determinant value. It is 0.33. Similarly, you can calculate the determinant value of all these. That is, here M21 is equal to minus 0.168. Then M22 is M22 is 0.69. M23 is minus 0.3975. M31 is 0.165. M32 is minus 0.294. M33 is 0.8. And I had already computed all these. That's why I'm just writing it down. You can compute it and you can see for yourself whether these values are correct. So now we have found out what is minor. Okay, now from minor you can move to the cofactor matrix. Cij. Cij is actually signed minor, isn't it? Minus 1 whole raised to I plus j into M11. That is C11, isn't it? C11 is minus 1 whole raised to I plus j means it is 1 plus 1, isn't it? 1 plus 1 into M11. C12 is minus 1 whole raised to 1 plus 2 M12. Right? C13. That's a formula you might have learnt earlier. Minus 1 whole raised to 1 plus 3 M13. That is how you compute the cofactor matrix. Cofactor matrix is nothing but it is the signed minor. Okay, by applying this formula, you will be able to get the cofactor matrix. Now let us write the cofactor matrix. Just a minute. Let me erase this because we don't have sufficient space. Since we have already computed the minors, it is possible for us to easily write the signed minor because cofactor is nothing but signed minor. Now let us, based on this information, let us now write the cofactor matrix. Okay, let us write the cofactor matrix. Yes, cofactor. How do you write the cofactor matrix? Yeah, Cij, cofactor matrix, that is equal to, just write the signed minor into a matrix form: 0.68, 0.235, 0.33. Then you have 0.168, 0.69, 0.3975, 0.165, 0.294, and 0.87. This is how you write a cofactor matrix. Now, what is basically adjoint A? Of course, what are we in the process of? We are trying to find what is inverse of I minus A, isn't it? We have already seen what is I minus A. Based on that, we have computed minor, we have computed cofactor also. Right now, we want to find what is adjoint, isn't it? Now, for that, first we have to transpose that matrix, isn't it? First, we have to find the transpose of Cij matrix, that is Cij transpose. When you transpose it, this can be written as 0.68, 0.168, 0.165, isn't it? So then you can write 0.235, 0.69, 0.294. Then again you can write 0.33, 0.3975, 0.87. So this is how you have found the transpose of the matrix. Now you want to find what is I minus A inverse, isn't it? It can be written as adjoint of A by determinant of I minus A. Adjoint of I minus A divided by determinant of I minus A. Determinant of I minus A is written like this into adjoint of I minus A, isn't it? I minus A. So this is the adjoint matrix, isn't it? This is the Cij transpose. And of course, we have already found what is I minus A determinant. Determinant value of I minus A, I think it is 0.537 15, which we have already calculated. So we can write this as 1 by 0.53715 into, just write this Cij matrix, okay, transpose matrix: 0.68, 0.168, 0.165, 0.235, 0.69, 0.294, 0.33, 0.3975, 0.87. So Cij transpose matrix. So that is how we find I minus A inverse. Okay, I minus A inverse can be obtained. Now, what are we in the process of? We are trying to find a solution to X, isn't it? X is something that we are trying to find out. That is, what is the amount of X1, X2 and X3 to be produced. That is, there are three sectors. Each sector is producing a particular product. Sector 1 is producing product 1, X1. Sector 2 is producing product 2. Sector 3 is producing product 3. So you want to find how many units of each of these products to be produced, because product 1 is an input in its own sector. It is input in other sectors. Similarly, product 2, it goes as inputs in various sectors. In product 3 is also going as inputs in various sectors. Apart from that internal input demand, you also have this external demand. To meet all that, how much units of X to be produced, how much units of product 1, product 2 and product 3 to be produced. So we have that formula I minus A inverse into D. That is the formula, isn't it? This is a formula we have: X is equal to I minus A inverse into D. So we have already found out I minus A inverse, that is 1 by 0.53715 into Cij transpose, this matrix. Okay, now this again into D also has to be found out. Let us again erase this because we don't have sufficient space. Okay. Okay, so let us write this. Let us try to solve for X, right? Yeah. Let us solve for X is equal to, the formula is I minus A inverse into D. Of course, I minus A inverse is 1 by 0.53715 into this transpose of the coefficient matrix. I shall write here that 0.68, 0.168, 0.165, then you have 0.235, 0.69, 0.294, 0.33, 0.397, 0.87. Okay, this is it. The adjoint matrix or Cij transpose into D. D, of course, we know that it is 100, then it is 200 and 300. Those values have been given to us earlier, right? Now what you need to do is that you just multiply this matrix with this column vector. You retain this as 1.531715. You retain it as it is. Then you multiply this coefficient, this matrix, Cij transpose matrix with this column vector, external demand vector. So you get 0.68 into 100 plus 0.168 into 200 plus 0.165 into 300. Right? Again, second row 0.235 into 100 plus 0.69 into 200 plus 0.294 into 300. Coming to the third row, you get 0.33 into 100 plus 0.397 into 200 plus 0.87 into 300. Okay, then again you can retain 1.05, 1 by 0.5 3715 into this. When you add up the first row, you will get I think you get 68 plus 33.6 plus 49.5, which is 151.1. And when you add up the second row, you will be getting to 23.5 plus 138 plus 88.2, that is equal to 249.7. Finally, in the third row, when you add it up, you will get 33 plus 79.5 plus 261. So you get 373.5. Now, each of these, okay, we have got a column vector and each of these values must be divided by 0.53715, that is 151, point 1 by 50.53715. So you get how much? You get it as 281.27. Then again 249.7 divided by 0.53715, you get 464.82. Similarly, 373.5 by 0.53715, you get 695.27. This is how you have arrived at a solution that is regarding how much of product 1, product 2 and product 3 must be produced by these sectors. You need to produce 281.27 units of first product, and X2 or the product 2 that has to be produced must be equal to 464.82. And finally, product 3 to be produced is equal to 695.27 units. So since all these sectors are interdependent, since each sector is producing a product, and the product is used as an input in that sector itself, and it also goes as inputs in other sectors. Apart from this input demand, there is also an external consumption demand. So you have to decide how much quantities of product to be produced by each sector, and for deciding that you need to use this method, input output analysis, and basically you are employing a matrix method. Okay, matrix format. You're actually constructing that, formulating the problem, you are translating that into matrix format, and actually you are applying inverse method. Okay, and based on that you are trying to find solution for that problem, how much quantity of various products must be produced by each sector. I hope it's clear, students. Anyway, you please listen to this video, and if you have any doubt, of course, you can approach me. Thank you.